Right, so I know it's already Tuesday, but that's our last section for the week. So 5, 6 is the end of what we're doing. We're going to split it into 2 days. Okay, we'll do part today, part tomorrow, and then Thursday the plan is for review. We'll do some kind of review. All right, so just to make sure we remember what the symbol means. What does that symbol mean? Like if you had to read it out. Chris?
Greater than.
Yep, that means greater than. Right? How about that symbol? Yeah?
Less than or equal to.
Yeah, how do you know it's not just less than? How do you know it's less than or equal?
There's a line below it.
Yeah, because there's a line below it. So when you see the line below it, it's less than or equal. Okay? So this is just like the one above without the line. So what's that symbol? Oh, Dylan?
That is the one at the bottom right now.
Yeah.
Less than.
Less than. Yep. So less than. And then the last one, just like the first one, except it's got the line under it. Lewis, what's that one?
Less than or equal to, no, greater than or equal to.
Yep, greater than or equal to. Remember, the way I remember less than is less than almost looks like an L that's kind of like bent. Like if this is an L, it's almost like it just bent in a little bit. So, less than symbol kind of looks like an L, but it's a little bent. All right, so we've been solving equations. What makes something an equation? What does it have to have in it to be called an equation? Yeah? Yeah, it has to have an equal sign, right? Well, so if we did problems like this yesterday, all we're going to do to make it a problem like we would do today is take away the equal sign and put something different there. What do you put there to make it an inequality? One of these 4 things. If you put one of those in, you just turn the problem from an equation into an inequality. So maybe something like that. The graphing is kind of what we're going to focus on with this stuff. So I know we didn't do a ton of graphing with solving equations because you could get decimals. We're not really going to get decimals when we do this. We're more going to get a picture and we're going to shade. Okay, that's pretty much how you solve these. You draw a picture. All right, so a linear inequality in 2 variables. The way we get it, I just explained it. Take an equation, just like we did yesterday. Okay, so something like that, and just get rid of the equal sign. Change the equal sign to a greater than, or a less than, or greater than or equal to. Just change it to one of those 4.
Does it matter?
No, you'll be given which one it is in the problem.
Yusuf, we're not going to ask you we're not going to ask you to write one. It'll already be given to you.
Like that.
I just want you to understand the difference.
Okay, so there's one where they gave it to you right there. If you put an equal sign in there, then it would have been the kind of problem we did yesterday. That has a less than, that's the kind of problem we're doing today. All right, so when we solved linear inequalities, or linear equations, the solution could have been one of 3 cases. What's one of the 3 things that could happen when we solved the problems yesterday? You could solve the system and get what for an answer? No solution. Yep, that could happen. What else could happen besides no solution? Gigi? Infinite. So we've said both the special cases. No solution, infinite solution. And then what's the normal thing that could happen? Yeah? One solution. You get an ordered pair, like an x comma y. All right? What's going to happen with these? They're all going to be infinite solutions. Pretty much. Unless you had one that was no solution. But I think all the ones we do today, they're all going to be infinite solutions. Okay? And you'll see what we mean by that. Okay, when we draw it out. So the solution to a linear inequality is any ordered pair, not just a single one. Any ordered pair, such that when you plug it in, you get a true statement. Let me just show you guys 2x plus y is greater than 0. Okay. That's a linear inequality. Kind of set up like an elimination problem, where the x's are in a column, the y's are in a column, numbers on the other side. Let me pick this point, 1 comma 2. Watch what happens if I plug it in. What's 2 times 1? 2. Plus y is 2. What's 2 plus 2? 4. Is 4 greater than 0? Yes. Then that coordinate right there is one of the solutions to that problem. Right. How about if I did this? X is 0, y is 4. What's 2 times 0? 0 plus y. Y is 4. What's 0 plus 4? 4. Is 4 greater than 0? Yeah. There's another coordinate that's a solution. There's an infinite amount. There's also ones that aren't solutions. Like if I started to pick some negative numbers, I might run into some problems. But I just showed you guys 2 coordinates that are solutions. Right? Let's do one more. Anyone think they could give me one more coordinate? They think when I plug it in, I would get a solution? Oh, Ryan? Pick any 2 numbers you want, and we'll check it. 2 and 4. All right. So he gave me 2 and 4. Yusuf, if I plug in 2 for x, what's 2 times 2? 4 plus, what did he say for y? He said 4. What's 4 plus 4? 8. Is 8 greater than 0? Yeah. So he gave me another solution. Right? We could go all day. You could just keep coming up with different ones. Right? So that's how you check if an ordered pair is a solution. Plug it in and see if you get something that's true. If you plug in a point and get something that's false, then it's not a solution. All right? So like if I let x be negative 10 and I let y be 0, that wouldn't work. You can try it. Plug in negative 10 for x and plug in 0 for y. You're not going to get a number that's greater than 0.
Yeah, and again, like negative 20 is greater than 0.
Yeah.
It's not true.
It's
That's
not
why. That's why in the normal guys we did those like 4 questions with it greater than and less than, just to kind of get you thinking about it.
So what we're going to do is we're going to give you guys some ordered pairs, and we're just going to ask you, if you plug them in, is it a solution or no? It's not a solution.
Hey, like this, guys. What's going to look like is we're going to give you the ordered pair. You can plug it in. If it works, great. It's a solution. If not, it's not a solution. So basically, it's like substitution.
So it says, tell whether the ordered pair is a solution. What's in the box? That's your inequality. What do they want you to plug in? They just put a little semicolon and then they put it after it. 10 comma 3.
It's just on the back side of your notes, that's all. Flip it over. That first box in the top left. All the examples on the back and the note, the writing stuff in the front, that's all.
I like the books.
So what
Thanks,
am I plugging in for x? What number?
10.
10. What am I plugging in for y? 3. So now, like Mr. Roy just said, let's just substitute that in. X is 10. 10 minus. Now you're not going to put y, we're going to fill in for y. What number do I fill in? 3. Is less than or equal to 6. So I just put a question mark there, because that's what I don't know. Is it less than or equal to 6? Well, let's find out. 10 minus, what's 3 times 3? 9. Is that less than or equal to 6? All right? What's 10 minus 9? 1. Now we've simplified as much as we can. We've done all the arithmetic. Is that true? Is 1 less than or equal to 6? What do you think, Savannah? Yeah, that's true. Okay, what does that mean? So 1 is less than or equal to 6. Yep, that's true. So now how do we answer the question?
What would we write?
No solution.
You agree what?
No solution.
No, the question's not asking how many solutions are there. Because I already told you, how many solutions are there to a problem like this? Infinite, right? Remember you guys kept naming coordinates? This is one of a bunch of them that would work. So, what should I write for the answer? Yes, exactly. Tell whether the ordered pair is a solution. The answer here, yes.
That's it.
That is a solution. Yep.
Plug the numbers in and say yes or no. If it's true, say yes. If it's not true, say no. Jay, what moment? Yeah.
Do we have one that's no?
We don't.
Okay.
We only had one last year today.
Let's do one like this.
So guys, if you have a little bit of room in that same box, just right up below it.
Let's do
number one box.
What is
Yeah.
Okay, so 2x plus y is less than 5, and I want you to plug in 1, 3. Okay, which number am I plugging in for x?
1.
Yep. What number am I plugging in for y? 3.
Say he wanted to give you one that was want to give you one of each.
So 2 times, what am I going to put in those parentheses? 1. Plus, what's going to go after the plus sign? 3. What else do I need to just copy down? Yep, less than 5. This is what we're going to figure out if it's true. One calculation, well, actually 2 calculations. What's 2 times 1?
2.
So we got 2. I'm just going to copy everything else down. 2 plus 3? 5. Okay, so first step to answer this, is 5 less than 5? No. Okay, so what does that mean about the point 1 comma 3? It's not a solution. So tell whether the ordered pair is a solution. No. It did not work. Now, if it said less than or equal, would it be a solution? Yes, because 5 is less than or equal to 5. But is 5 smaller than 5? No, they're the same. So that's an example of one that doesn't work. Okay? We could come up with a bunch that don't work. We could come up with a bunch that do work. Right? And we're going to see, how do you show all of the ones that work? Like, you can't just sit here all day and just keep writing down the ones that work. If there's infinitely many, it's going to take you a little while to write all those down. So rather than actually writing them, we're going to end up drawing a picture that shows. Yeah, so it's going to be visual what the solution is. Okay. Mr. White, did you want to?
Yeah, I'll do this. So like, guys, like we said, we were just giving you, like we gave you a coordinate and we asked you to plug it in to see if it worked. Now, like Mr. Hager said, we're going to have to, like on the test, we're going to give you a couple like the one we just did. We're going to say, is this a possible solution? Okay, check it, yes or no. All right, but we're also going to have to graph them. And when we graph, we're going to have to graph them. Mr. Hager said, like shade them in. Like that's what we're going to look at right now. So once we draw a line, we have to shade a certain region of the graph based on the inequality sign. So you have to look at this. You have to look at the sign. And when we're going to give you, you can see on the front side of your notes, we're going to give you a chart. I think it says like inequality sign on the problem, boundary line, and then area to shade. So depending on what type of inequality sign you have, you may draw a dotted line, you may draw a solid line. You may have to shade above that line, you may have to shade below that line. It all depends on what the inequality sign is in that particular problem. And then what you shade, any coordinate in what you shaded is a solution to that inequality. So here we kind of just, when we did those first couple examples, we just kind of highlighted and say, okay, see if this works. Now we're going to graph it, and what you graph, everything that gets shaded in is a possible solution to that inequality. We won't make you pick one or anything. It's just so you can see anything that's shaded in will be a solution to that inequality. All right? So this is the stuff you want to write down, guys, on the front side of your notes. So just like when we did graphing, like slope-intercept form, so these are linear inequalities because of the signs. Because of these. Remember we said there's no equal sign? We're going to put an inequality sign instead. That's what makes it an inequality. But in terms of graphing it, we're going to graph it the same exact way as we would graph a linear equation. Meaning we would graph it the same way as a problem that has an equal sign in it. We want to graph it the same way. The only thing that's really new with this is shading. Everything else how you graph it is the same way. Alright? So you want to make sure the equation is in y equals mx plus b. This is why we broke this section up into two parts. Today, every inequality we give you will be in slope-intercept form. Meaning you'll just be able to go ahead and graph it. You won't have to move anything, you don't have to divide, you don't have to do any of that. The stuff we do tomorrow is when you'll have to rearrange and make sure it's in y equals mx plus b before you can graph it. So today, they're all going to be set up for you. You can just go ahead and graph. Tomorrow, we'll have to do some rearranging. Alright? So you want to make sure it's in y equals mx plus b. Everything we do today is going to be in y equals mx plus b. We're not going to go through these steps again tomorrow. Alright? The only thing that's going to, like I said, the only thing that will change tomorrow is the ones we do tomorrow, you'll have to rearrange to make sure you get it in y equals mx plus b. But in terms of graphing it, the steps are the same. Alright? So we want to plot our points, right? M and B on the coordinate plane. So if we go back and look at slope-intercept form, right? The M, can someone tell me what the M stands for? What it represents? Anybody remember? Yeah, M is going to be the slope. The B is going to be your y-intercept. Alright? So the B is going to be, so you have, it says on your notes, it'll say B. You're just going to fill in y-intercept. And I believe it says when graphing, that's where you're going to start at whatever number that is on the y-axis. So B is your y-intercept. It's the number with nothing, there's no variable attached. It's just a number. It's the last thing in the problem, last number in the problem. When you graph it, remember that you want to start at that number on the y-axis, which is the vertical line. M, right, like Nicole just told me a little while ago, M is going to be your slope. Remember, the slope is always going to be the number with x attached. It's kind of like a little reminder to say, hey, right next to me, that's the number, that's the slope. Alright? When you're graphing, graph your y-intercept first, then to your rise. On your notes, guys, you should have a line like this. Remember, we talked about this a little bit yesterday. We did graphing with the systems. Rise over run. Remember, if the number on top is positive, we want to go up. If it's negative, we want to go down. Bottom number, almost always, 95% of the time, we're always going to go. If it's a negative slope, we go down to the right. If it's a positive slope, we go up to the right. The only time we go like down to the left is if we were like running out of space on the graph and our next point was going to go off the graph, like it was a positive slope, but the next number we graphed it wouldn't fit, then we go to the opposite, go down to the left. Right? Same thing if it was like a negative slope. If you were going down to the right, we're going to run out of room, you can go up to the left. So remember, slope is rise over run. Like I said, 95% of the time, if it's positive, up to the right. If it's negative, down to the right. You're always going, on the bottom, you're almost always going to be going to the right on that bottom number. Remember, if it's you don't have to write this, but if it's a whole number, say if our slope was 3x, so we're kind of imagining now that I already graphed my y-intercept. So I'm at my y-intercept. This is my slope. What is that slope telling me to do? Go in what two directions? If my slope was 3, right? What is that telling me to do? Where should I go? Say it, Nicole. Up 3, then you say over. What direction? Up to the right. If it was -5, say that was my slope. I'm at my y-intercept. Brady, where am I going to go? If my slope is -5. What two directions am I going to go in?
Down.
Down, how many?
Down 5.
Down 5, and then where? Be
Left,
specific.
Left. I don't know.
What's the only other choice? If we're not going left, we're going
Right.
right. Remember, even if your slope is negative, you're still going down to the right. You're still going down to the right. Right? You're going to draw your line through your point. I mean, you only have to graph like 2 or 3 points. Graph your y-intercept, and then do your slope a couple times. And you're probably going to want to use the side of your ID or some kind of a straight edge to draw your line. Right? And then you're going to shade. Alright, we're gonna get into how you draw your line and how you shade in just a second. Alright? So draw your line through your points and shade. So that little chart that's on the front side of your bottom, like the bottom of the notes there, that's what you're gonna want to use. Alright? So I know we did this in the warm-up, and we did it at the beginning of the notes today. Can someone remind me, what does that sign mean? Right, like Nicole just said, less than. Meaning if it's less than, the line that you draw through your points, you want it to be dotted. So take your side of your ID and just you want to make sure your lines are dotted. Alright? And then when you shade it, you want to shade below that line. Right, you're just going to kind of shade it a little bit below the line. Above, below. Right, you want to shade below it. Then we have a less than. So we know this is less than. This is with the line on the bottom like we talked about. That's going to make it less than or equal to. Only difference here is how your line is going to be drawn. If it's less than or equal to, you want your line to be solid. But same idea, you will still shade below that line. It's kind of like when we were doing like inequalities, we had to graph them on the number line, and we had like the open circle and the closed circle. Remember, the closed circle meant that even the number that it was at on the number line could be included in your solution. Any coordinates on a solid line, if it's a less than or equal to, any numbers on any coordinate on that solid line, it could be a solution to that inequality. If it's dotted, it cannot. So that's the difference. That's why we draw it dotted and solid. If it's solid, any coordinate on the line can be included. If it's a dotted line, if it's a coordinate on there, it cannot be included. It can't be on the line. Then you just got a greater than. Same idea. There's no line underneath. That means you're dotted. There's no line underneath, whether it's a less than or a greater than. We're going to draw it dotted. We're going to shade above. I don't care if it's a greater than or or equal to. You're always going to shade above. If it's a less than or equal to, you're always going to shade below. And then you got less than or equal to, dot, it'll be solid, because I always think to myself, when it has the line underneath, that's like a reminder to make sure that you draw your line solid. Just like when we did inequalities graphing on a number line. If there was a line underneath, we made our dot solid. If there's a line underneath when we graph these, we want to make sure the line you draw is solid. So like, you can think of it two ways. When you have the line underneath, they kind of go together. You want to make sure you draw your line solid. No line underneath, dotted. Less than or equal to, below. Greater than or equal to, above. And on the reference sheet, guys, for this week's test, this exact same chart will be on there. You just have to fill it in. And if that's one thing you're struggling with and you can't remember, that might be the only thing you want to fill in on your reference sheet, and that's fine. Okay? So, and again, I know there's another box next to it that talks about like special cases. We're not on that yet. We're going to get to that in just a second. Alright, so people are good with this? Alright. So, if we look at it, right? So on the back side, it's going to go in the example 2 box. So, if we look at step 1 on the steps to graph inequalities, what is it? Someone tell me by raising their hand. What's the first step? What's the first step to graph inequalities? Eugene?
Make sure equation is in y equals mx.
Yeah, and it is, right? We got y by itself, we got the sign, number with x, just a number. Alright? We have all those things. Like I told you guys, everything, the ones we do today are going to be set up in y equals mx plus b. We don't have to do any rearranging. That'll be tomorrow. Alright? So it's already in y equals mx plus b. So what do we have to identify? What two things do we have to identify now? What's one thing we have to identify? It's one thing you have to identify to be able to graph it. Dylan?
Y-intercept.
The y-intercept. In this problem, Dylan, what's my y-intercept?
3.
3. Yeah. My y-intercept here is 3. Make sure you include the sign to the left of it. That's important. So this is my y-intercept. I'm going to start my graph there on the y-axis. All right? So, Bethany, where's 3 going to be on the y-axis? If I want to graph the number 3 on the y-axis, where would it be? Is it going to be the horizontal line or the vertical line? Vertical. All right. Where am I going to go? Up 3. That's it. I'll put a dot at 3. All right. So once I've done that, I'm done. Once I've done that, I'm done with my y-intercept. I don't need it anymore. It's kind of like, you know, it's like think of it as a game. Like you're rolling the dice twice. You roll the dice once to start, right? That tells you where to go. Then you roll again to see where you're going to go from there. All right. So we rolled the dice once. We're at 3. What are we going to use now? We already used the y-intercept. So what's the only other thing in the problem I can use? The slope, right? So in this problem, Nicole, what's the slope? Yeah. Then I'll use this is my slope. What's the slope telling me to do? Yeah, I'm going to go up 1. It's 1 over 2. So I'm going up 1, right, 2. Remember now, we're not going back to the origin. We're going, like I said, think of it as a game. We rolled the dice once, we're here. We rolled the dice again, we got this. So now we're going to go up 1, right 2, 1, 2. Up 1, right 2. If you do it like 2 or 3 times, say do it 2 or 3 times, that should be fine, right? Yeah. Yeah, if you do it 2 or 3 times, that should be good. So now we graphed it. Now what do we have to decide? What should I be looking at now to help me? So I've used the y-intercept, I've used the slope. What's that? One other important thing in that problem. Melanie?
You have to decide which line.
And what's going to tell me that, Melanie?
The sign.
The inequality sign, right? Let's take her finish what he's doing. Alright, I'm going to look at the inequality sign. So based on that inequality sign, Melanie, what type of line am I going to draw?
Dotted line.
Dotted line, right? Mr. Hager's going to do that. He loves doing this. It's like one of his favorite little lessons here. He shows artistic abilities. Perfect. So there's our dotted line. So again, the inequality sign tells us 2 things. We've already figured out one of those 2 things. What type of line it's going to be? Like Melanie just said, it's going to be dotted because there's no line underneath. So we figured out what type of line it's going to be. What else do we have to figure out? Melanie?
Where to shade?
Where am I going to shade?
Below.
I'm going to shade because it's a less than, so I'm going to shade below my line. Mr. Hager's going to shade. And guys, when you shade, it doesn't have to be perfect. You can just kind of, like we have because we have like the highlighter thing on this, we can be, you know, you don't have to do it perfectly. Like if you just kind of go, it doesn't have to be perfectly, like if there's some clear space, doesn't matter long. You can just go like real quick just to show us. It doesn't have to be perfect. All right. So what does that mean? What does that mean? It means any coordinate in this shaded area could be a solution to this inequality. And remember, we're only seeing a portion of this coordinate grid. This coordinate grid goes on forever. That's why Mr. Hager said it's an infinite number of solutions. But nothing up here would work. And remember, because this is a less than, any coordinate on the line would not work. Because it doesn't have the line underneath. It's not a less than or equal to. It's not a greater than or equal to. That's why we make the line dotted to show that nothing on that line could be, no coordinate on that line could be a solution. So before we gave you a coordinate and we asked you to see if it worked. Now, like Mr. Hager said, here's a picture to show you that anything in this region could be a possible solution. It's not possible, it's definitely a solution to that inequality. I could pick any coordinate, plug it in, it would work. And guys, it could be decimals too. It could be like, 2.5 and negative 7.2. So it's any number in that region would work as a solution. Alright? So that's how we do it. So like I said, graphing it in terms of like the way we do it is the same as slope-intercept form. Use the y-intercept, then use the slope, look at your sign, see what kind of line you're going to draw, see how you're going to shape. So y-intercept first, then the slope, look at the sign and see what kind of line you're going to draw and where you're going to shape. Oh, that's really, whoa, I don't know what that looks like. Mountains, like a mountain range. All right, let's look at this one. So it's going to go example 3 on your notes. So Catherine, what do we need to identify first to help us graph it? Where do we start? What do we use to start? I'm not sure, you can look at your notes too. Where do we start? Again, there's only 2 numbers there. We have a -2 with the x attached, and we have the 1 attached. Why are we going to start at 1? What is it? Y-axis, okay. So I'm going to go here from the origin, and I'm just going to go to 1. We're starting at 1 because 1's the y-intercept. Once I use it, it's done. Once I use this positive 1, it's done. I don't need it anymore. Again, it's like rolling the dice. I roll the dice once, it tells me where to go. Then I get to roll the dice again. It's like I get a free turn. I get to roll the dice again. All right. From that 1, where do I go? What do you think, Yusuf?
Down.
Down how many?
2.
Down 2. Then where?
Over 1.
What do you mean over?
To the.
To what?
Hold up.
Okay.
To the right.
Good. Remember, we're always going down and to the right, even if it's negative. Right 1. Where'd you get that from, Yusuf? That information.
Same stuff.
Where'd you see it? Where'd you see it in the problem?
I just put in my mind that this would be a fraction, so.
Yeah, but right here. Because this is the slope, right?
Yeah.
And that's what it translates to. My slope is -2, like we said in the notes. Slope always has the x attached. So the number with the x attached is the slope. It's telling me to go down 2. And remember, we have to know if it's a whole number, it's always over 1. You have to know there's like an imaginary 1 there. It's like an imaginary. You have to know there's like an imaginary 1 there. So like Yusuf said, I'm going to go down 2, 1, 2, right 1. Down 2, 1, 2, right 1. Down 2, 1, 2. All right? So we did that. So we used the y-intercept. We used the slope. What's one more important thing in that problem, Ryan, that we're gonna need to use?
It's a solid line.
Solid line or a dotted line? What do we look at to determine that? The inequality sign, right? You said solid. Why do you say solid, Ryan?
That's the line.
Yeah, remember, this is like a little reminder to tell us. It's like a little reminder to tell us there's a line underneath. Make sure your line's dotted. Just like when we did these back in like the fall. If there was a line underneath, make sure your circle, or your dot, was filled in. It was solid. Same idea here. All right. So Mr. Hager drew a solid red line. So that sign, that inequality sign, tells us two things. First thing, what type of line we're going to draw. Second thing is what? Where we shade. All right. Donovan, for this one, where am I going to shade?
I don't know.
Not sure? Look at your chart. You fill it in on the front side of your notes?
I didn't get that.
You didn't fill it in? Okay.
Below.
Below, right?
What?
We're gonna shade. I think of it too. Even if I didn't have it on my chart, I think of it like this. Where would all the numbers be? I think of it as where would all the numbers be that are less than? They'd be below the line. If it was a greater than, it would be above the line. Or another way you could think of it for these is, see how my arrow is pointing to the left? It's pointing this, kind of like remember we did them on the number line. You had to put the dot and you had to draw a line going in the direction of the arrow. You can think of it like that too. My arrow's pointing left. I want to shade to the left. If it was like a greater than, like that, my arrow's pointing to the right. I want to shade to the right. So if you forget, right, or you didn't fill it in, or you don't fill it out on the reference sheet for Friday, just think of it. If my arrow's pointing left, just like when we did the ones with the number line, you drew your line to the left. Here, whether it's a less than or equal to, or a less than, you're going to shade left. If it's a greater than, or greater than or equal to, meaning my arrowhead is pointing right, I want to shade to the right. That works out fine for these. We're going to get to something in the next thing we do, that won't work so well. All right, when we get to the special cases. But for these, when it's a regular inequality, not a special case, if you look at the direction the arrow is pointing, you can shade in that direction of the line. All right, if you don't have it filled in on your chart. And there you go. So this only difference is here now, any coordinate that's on the line would work as a solution because it's less than or equal to. Those numbers can be equal to. So anything in pink or on the line can be a solution. But again, guys, we're not going to ask you to explain. We're not going to ask you to explain. We're just going to ask you to graph. Right? And some on the test may be like multiple choice. So you're just going to make sure you pick the right graph. That's shaded correct. Right? Alright, so Mr. Hager said any coordinate in pink or on that red line could be a solution, is definitely going to be a solution to the inequality. Alright, now, if the linear inequality only has one variable, meaning like y, and then one of the signs less than or equal to, greater than or equal to, and then just a number. So there's only one variable. We call that a special case. Kind of like when we did it with we did linear, we graphed like linear equations, and we had like y equals 3, x equals -2, right? This one here was a horizontal line. This here was a vertical line. Right? Those were special. You don't have to write that down. That's why I kind of want to show you the connection. So, kind of similar when we do it with a linear inequality. All right? So, meaning now there's going to be an x and no y, or a y with no x. You only have one variable. So, y only. Like I said, with no x. Here's your example. Here would be an example. Y is greater than 3. There's no x. You only have one variable. You're going to draw your line horizontal. Right? You're going to draw your line horizontal, meaning you want to draw your line across. Now, if it's in terms of what type of line, whether it's solid or dotted, you can follow the same rules as from the chart before. It'll still be solid or dotted. That doesn't change based on a special case. Now for this says greater than. So if it's greater, if it's greater than or equal to, you shade above. So the shading for this special case doesn't really change. You can still think of it as, if it's greater than or equal to, you'll shade above. If it's less than or equal to, you'll shade below. Right? So for this type of special case, it doesn't really change anything. Because you can still be above the line, you can still be below the line. Because the line's horizontal. There's still an above and a below. Now, if we look at X only, meaning no Y. So it's, in this one we had X is less than or equal to -5. Alright? Your line is going to be vertical. Right? So I want to find, I'm going to find -5 on the Y-axis. Now I'm going to find -5 on the Y-axis, on the X-axis rather, and put a dot. And then draw my line going up and down. If it was like this one with the Y only, I'd find 3 on the Y-axis and draw my line across. So similar to what we do if it was a linear equation, the only thing that's different is shading. For the Y only, the shading doesn't, like I said, the shading doesn't really change. You still have an above, you still have an below. But for shading where you have an X only, you don't have an above or below. You have a left and you have a right because the line is vertical. So you can't do above and below. It doesn't work because you don't really have it. Alright? So if we have greater than or equal to, you're going to shade to the right of the line. And then for this, if it's less than or equal to, you shade to the left. So like I said, if it's an X only, that's when you change. That's when it changes a little bit, right? So these are your special cases. But that little trick I talked about earlier, where you look at where the arrowhead's pointing, you can use that for this. So if you forget, like, okay, my arrow's pointing to the left, I want to shade to the left. All right? So those are special cases. And on the reference sheet, this chart will be on there as well. All right? Alright, so these ones are, I think the special cases, they're a little bit quicker because you only have to graph one point. You only have to graph the one point on whatever axis it is. So for this one, what number am I going to graph on what axis? And what axis am I going to graph it on?
Would you do, because I know that it's like less than, or it's greater than or equal to.
Okay, I agree with
So
that.
I know that it's going to be positive, so when I graph it at 2
On what axis?
on the y-axis.
Perfect. Graph 2 on the y-axis. Jacob, do you know which way my line's going to go? Is it going to go across, or is it going to go up and down? So horizontal or vertical? This is a Y only. Huh? Look at your chart. Go to the front side. Look at your chart. If it's a Y only, which way is my line going to go?
Horizontal.
Across, right? Now, do you know what type of line it's going to be? Is it going to be solid or double?
Solid line.
Why is it solid?
Because it has greater than equal to.
Yeah, it has the line underneath, right? So Mr. Hager's going to draw the line for us.
Beautiful line.
Like Jacob just told us, it's going to be solid because there's no line, there's a line underneath. What's the last thing I have to figure out?
If you have to shade it or not.
So what do you think? Above or below? It's a greater than, right? So where would all the numbers, where would the numbers that would be greater than be? Above it or below it?
Oh, below it.
Above it. You want the numbers that are greater than, so you're going to shade above.
Stop confusing.
Again, if you forget, that's all, I always think of these like that to myself. I'm thinking, okay, where would all the numbers be? Because it says Y, you don't know. Where would all the numbers be that are greater than 2? It would be above the line. Donovan,
On
question?
the test, are you just gonna give us a graph without any numbers, and then we're gonna have to like say the coordinates?
No. The only time we're really gonna be worried about, no. I mean, the only time we're really gonna give you a coordinate is like that first example we did. Like, will that coordinate work as a solution to
Alright,
that inequality?
yeah.
But we're never gonna ask you like, okay, pick a coordinate from what you shaded in. We just want you to be able to graph it correctly. Again, some of them on the test will be multiple choice, so you're just gonna make sure you pick the right graph. You won't have to graph it. Some of them you'll have to graph, others you have to pick the right graph. That's all, it already be done for you. So again, like Mr. Hager is saying, any coordinate on the line or in the green section is a solution. It's not a possible solution, we know it's a solution. Alright? So that's one special case where again it was Y only. Alright. Hold on, let me go back. Okay, this one. Special case. Meaning I gotta graph a number on an axis. So what number do I have to graph? No, one axis. Jake?
3 on X.
3 on the X. Is that gonna be to the right, Jake, or to the left?
Right.
To the right. I'm gonna put a dot.
We're gonna shade below it, right?
Jacob?
Up and down.
Up and down, what kind of line?
Vertical. No.
Okay, so it's gonna go up and down, so vertical. What's it gonna look like? Dotted or solid?
Dotted.
Dotted because
There's no line.
no line underneath. Good. So Mr. Hager just drew it. There's my dotted line. Going through, like Jacob said, he wants it up and down, he wants it vertical, going through 3 on the x-axis. Shading.
Would it be like that?
Am I gonna go, now this is a special case, so am I gonna be on,
Right side?
am I gonna be on the left or am I gonna be on the right?
Right.
Look at your arrowhead.
Oh, left.
Left, right?
Yeah.
Again, if you forget, the only time the arrowhead wouldn't really be helpful to you is when it's a Y only, because there's above and below. Again, guys, if you do it like this, just do like a checkerboard pattern like that, that's fine too, we'll understand, we'll know what you mean. We're not gonna test you guys on like your coloring skills.
You should test it.
But if you want, some people get fancy with it, if you wanna do that, that's fine too, but again, it's gonna take up more of your time. So that's enough, so we gave you a special case with that Y only, we gave you a special case with an X only. Okay? So homework tonight, guys, leave that up, I want you to do a couple of those practice problems before you go. Homework tonight, 5.6 worksheet. I think there's like 8 problems, so there's 6 questions on the stuff we did today, then there's 2 on the back that deal with the stuff we talked about yesterday. Alright? We talked about, I'm not sure Mr. Hager talked about this before I got up here. This week's homework, so the stuff we did last night, tonight, tomorrow night, and the test review on Thursday night, all those homeworks will count for third quarter, right? The test is gonna count for next quarter, because in that way we'll have 4 for third quarter, 4 tests for fourth quarter, alright? I don't know if anybody checked off Google Classroom yet. The reference sheet is posted. I did put on there, it's optional. You don't have to fill it out. You can only fill out a couple boxes if you want, a couple examples, and it's entirely up to you. If you don't do it at all, it's not gonna count against you, but again, with the shading and knowing how to shade above and below what kind of line, it might be helpful this week. Even if you fill out that chart only, it might be helpful. But it's on there, so if you wanna go through, like tonight where the homework's not super long, you may wanna go and fill the examples in from yesterday, 5.4, and the examples from today, 5.6 part 1. Obviously, you won't be able to fill in 5.6 part 2, we haven't done it yet, we'll do it tomorrow. Mr. Hager, I'm just trying to be like you, buddy. And then, like we said, after school, we're both, I know, some of you guys need to know though. After school, we'll both be here on Thursday. I plan on being here like 3:45, 4 o'clock. If anybody wants to stay to get their reference sheet ready, review, whatever. It's better to put the time in now rather than July and August. And again, it's only for a small number of you guys. Most of you guys have done well this year, but there are that small, number of you guys out there that are in that situation, and we still don't see you putting in extra time to make sure you're not here during the summer. Cause he mistaken you. He's not gonna be here.
Oh, yeah.
I'm not gonna be here.
You're gonna be doing
Alright, I'll be cutting grass. Alright? So you don't want, believe me, you don't wanna be here. Jacob?
At least I have AC.
I'm really hoping that I don't get going here because there's one reason. One's my cousin's graduation on in July.
Yeah, so you don't wanna be here. Alright, so that's that. So you guys got a couple spots on there.
Are we going July?
Alright, so do this one right now. On your note.